Therefore, we have the constant keyword, which we spoke about a little bit in an earlier video. Now let's check it out in more detail. Here I have a whole bunch of typical uses of the constant keyword. So here's what's going on. Right over here I'm creating a regular integer x, giving it 0. Over here I'm creating a constant integer y, which of course, as we learned, will cause this variable y to never be changeable. It will always have the number 0, and never throughout the whole program will you be able to give it a different number or something like that. You could of course still use it for other reasons, like using it as an expression. So for example, in my program, of course I can have x equals y, which uses y as an expression to be assigned to the variable x. However, I cannot possibly have y equals x, which is going to try to assign the value of x to y, and unfortunately we cannot perform any assignments on the variable y anymore, because it was already assigned something as soon as it was born, and we promised the compiler that it's going to stay that way forever when we said the word constant. So right from the start you can already see two of the very basic rules of constant variables. Rule number 1: when you make a constant variable, you must assign it a value on the very same line that it's created. So as soon as the variable is born, you must right away assign something. Unlike the variable x, for example, which I could create on one line and then assign it a value on a different line, because this variable is flexible, it's changeable. However, because this one is constant, you cannot wait for later to assign it a value. You must assign it a value as soon as it's born. The other rule is about casting when assigning one variable to another variable. We spoke a very little bit about casting, which is about when you assign one variable to a different variable, of course they must be of the same type. For example, if y was not an integer but, let's say, your own custom-made soldier, which of course wasn't constant, and x was an integer, you cannot possibly assign an integer to a soldier. They are not at all of the same type. When you assign one thing to the other thing, the program will try to cast one to the other to see if they match. And even though they may not be the exact same type, they have to at least be a similar type, which is why you are able to cast a float to an integer or a character to an integer or something like that, because they are still number variables and they are basically somewhat convertible. However, when you include the constant keyword in the creation of a variable, it makes a very interesting rule of casting. You can cast a constant variable to a non-constant variable, but not the other way around. So this is a one-way rule of casting. Usually if I can cast one thing to the other, I should be able to cast the other to this, because in a way somehow the types are apparently matching, because it's possible to cast one to the other. But with the constant keyword, it only works one way. Constant can be used as an expression which can be cast to be assigned to a non-constant. You cannot possibly have it the other way around. So this is how you make a plain old type to be constant. You type the constant keyword, and then the type, whatever it may be, an integer or a float or your own custom soldier or whatever you want it to be, then the variable name, and then you just treat it like a regular variable, except that you cannot change its value. The truth is, actually, you can reverse the order of the constant keyword and the type of variable that it is. So you can type integer const, which is just as good as typing constant integer, has the exact same effect, no differences, except that programmers prefer to type constant integer because it makes a little more sense in English that this is a constant integer variable, not the other way around. Okay, now let's move on to pointers. Right over here I'm creating a plain old pointer of type integer, and I'm calling it ptr1, and I'm assigning it to 0, which means that I'm making this pointer null for now. Now here's the important part. Over here I'm creating a pointer of type constant integer, which means that we are promising the program, the compiler, whatever this pointer will be pointing to will not be able to be changed around through this pointer, because whatever this pointer will be pointing to will be considered constant. Now, I said it will be considered constant because it doesn't necessarily have to actually be constant. And what I mean is like this. I can assign the address of the variable y to this pointer. This would be the simplest example over here, which makes the most sense because we created a pointer which points to constant integer, and y is actually a constant integer. And just as when I try to use the constant integer y to change its value, like if I try to assign a different value to y, I will get a compiler error because it's constant. Same thing will happen if I try to dereference pointer 2 over here and then try to assign it some different value or something, trying to change it with whatever operator we'd like to change the value. We will get a compiler error because pointer 2 is a pointer which cannot possibly change whatever it's pointing to, because whatever it's pointing to is constant integer. Now here's what's interesting. I can even assign the address of the variable x, which is a plain old integer x over here, to the pointer 2, and this will compile and run with no problems. Something like the rule that I said before, that actually, sorry, the exact opposite. It looks like the exact opposite of the rule that I said before, that constant can be cast to non-constant, but not the other way around. Over here, it looks like we are doing the other way around. It looks like we're trying to assign the address of a plain old changeable non-constant integer to a pointer which we declared will point to a constant integer. Well, what happens in this situation is pretty interesting. The variable x is still, it remains not constant. You can still continue changing around the variable x however you'd like, assign it to different values and do whatever you want with it. The variable x is still a changeable variable. However, the pointer over here, pointer 2, will think that it's pointing to a variable that's not changeable, which is why if you try to do the same exact operations that you're trying to do on the plain old variable x, if you try to do that by dereferencing pointer 2, like dereferencing pointer 2 and changing it to something else, etc., you will get a compiler error. And that is because from the perspective of pointer 2, what it's pointing to is constant. It's a constant integer like we declared right over here. Even though we know that behind the scenes really the variable x is changeable, it's not constant, but pointer 2 looks at the variable x as if it's constant, and thus it will not allow you to change it. So here are another two rules that we learn over here. First of all, when you create a pointer which points to a constant something, which by the way again you can do that in the reverse order. You can have first a type and then constant like I said before, just that programmers like to have it in the regular order of constant type, not type constant. Such a pointer could be given the address of a constant as well as a non-constant. Both of them are valid. The only difference is that the pointer will treat both constant and non-constant as being constant. So like I said, pointer 2 can point to x and it could point to y, but it will treat both of them as if they were both constant, which is why you cannot dereference pointer 2 and start changing around the variable that it's pointing to, even though you can do that directly onto the variable x. Another rule is, notice that what we did over here was make the variable that's pointed to constant, at least from the perspective of the pointer. But the pointer itself is not constant, as we will learn that a constant pointer means that the pointer can't change from one thing to another, However, this pointer over here can change. You can make it point to x at first and then later on change it to point to y.